On to learning target 1C, the real number system. So we're still in unit 1, we're still just dealing with expressions, and in learning target 1C, the real number system, we're going to get a lot more vocabulary words that talk about what are different types of numbers. So by the end of this lesson, you will be able to state which subsets of real numbers any number belongs to. So the real number system is broken up in kind of two separate categories, and then within each of those categories, we have some more terminology. So the real number system is broken apart into two types of numbers, rational numbers and irrational numbers. So let's start with rational numbers. So rational numbers are any number that can be written in the form a over b, where a and b are integers and b does not equal 0, because we would not want to divide by 0 in a math class. That will give us an invalid answer. So rational numbers, a lot of people think about them as well. They're all the fractions. Anything that can be written as a fraction, whether that's a fraction, let's say like 2 over 3, or technically 5 is also a rational number, because I can rewrite this as 5 over 1 then. That's not a 6, that's a 5. 5 over 1, since I can take any integer value and write it as that integer over 1. Another way to define a rational number is a rational number in decimal form is either a terminating decimal, meaning like 2.3, so the decimal stops, or a repeating decimal, so for example 1.333 repeating, because I have that same pattern of all threes that continues on forever and ever in a repeating decimal. So our rational numbers is making up part of our real number system down here in our diagram. So I'm going to fill in some of these examples. So we had 2/3. We said 5 was a rational number. We have 2.3. We have 1.333 repeating. To get us some variety, I don't want you guys to think that I can't have negative numbers. I absolutely can have negative numbers. Maybe I have negative 1/4. Maybe we have negative 1,000, that would work. 0 is also a rational number, so that's starting to get us some examples here that we have. Irrational numbers, so our rational numbers are all over here on one side. Our irrational numbers makes up the other part of our real number system. So irrational numbers is any number that cannot be represented as a quotient of two integers. So in particular, an irrational number in decimal form is a non-terminating, non-repeating decimal. So the most common example that we have is pi. So pi, if you were to type it into your calculator actually can't tell you all of the decimals of pi unless you've got it set to giving you an infinite amount of numbers. So pi is approximately 3.14, but it does continue. It doesn't just stop after 3.14. It doesn't terminate, so this is a non-terminating, and it's also non-repeating. So there is no pattern to the decimal expansion of pi, which is what makes it an irrational number. So down here in our table, I'm going to go ahead and list pi as our first irrational number. Another common example that you'll see is some square roots. So any square roots that are not perfect squares would be an irrational number. So for example, the square root of 2 is an irrational number because 2 is not a perfect square. The square root of 5 is also an irrational number. And I could also go 3 times an irrational number will also still give me an irrational number. So 3 times the square root of 5. Together, our rational numbers, so remember, our rational numbers are our fractions or our terminating or repeating decimals. So the rational numbers and the irrational numbers form the set of all real numbers together. So the real number system is made up of these two types. I'm either a rational number or I'm an irrational number. It is not possible to be both a rational or an irrational. So on the side, it's a good thing to know. It is not possible There we go. Not possible to be both a rational and irrational number. A shorthand number with the pound sign. Okay, so it is not possible to be both a rational and an irrational number. I am either one or I am the other. Now within the rational numbers, so within these guys over here, I have lots of different types of numbers. Okay, so within the rational number system, there's a bunch of different types that we're going to define from here. The first one that we're going to define are the natural numbers. So the natural numbers are what we call the positive counting numbers. So if I were to list them out, those would be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so on and so on. So I'm going to represent all the rest of those with this dot, 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 meaning this list continues on forever in the positive direction. So it goes up to all of those positive counting numbers. So 1,000, 1,001, 1,000,000, 2,050, all of those positive counting numbers are our natural numbers. The next set we have is our whole numbers. So our whole numbers are all the natural numbers. So all of the natural numbers are part of the whole numbers, and one more. I also get the number 0 now. So the whole numbers start at 0 and they go up all the positive counting numbers. So 0, 1, 2, 3, 4, 5, so on, all the way up. Now our integer values, let's use purple. Our integer values are all the whole numbers and their negatives. So for our integers, I get all of those whole numbers. So I have 0, 1, 2, 3. I'm not going to list too many here this time. We know this keeps going on forever in the positive direction. But I also get their negatives. So I get -1, -2, -3, -4, -5, -6, so on and so on and so on with all the negative numbers. So the integers are what we're used to seeing on a number line. So if you've seen a number line before and all those tick marks on it are usually the integer values. So all the negatives, all the negative counting numbers, 0, and then all the positive counting numbers. So together, these guys make up our real number system. So I'm going to zoom out a little bit so we can see all of these together. So we had our real number system before. It was split up into two. Our rational numbers on the left and our irrational numbers we put on the right. But really, I can continue to break apart those rational numbers. So if I pull this back out, our irrational numbers haven't changed. So why don't we list all of those that we had prior? So what did we have up here? We had pi, square root of 2, and 3 square root of 5. So I'm going to list those down here. So our irrational numbers, I still have some of the same examples. Would be pi, square root of 2, 3 times the square root of 5. And then we also have our rational numbers. And within the rational numbers, we had all these different types. The integers, the whole numbers, and the natural numbers. So we're going to go ahead and list some examples in each, and I'm going to use our prior examples from up here. So our first one we had is this 2/3. So 2/3 is a rational number, but let's think, could it be, the next level would be, is it an integer? Is 2/3 also going to give us an integer value? In this case, it's not going to. So 2/3 is just a rational number, so I'm going to list it out in this portion. I can't include it down in the integers. The next one on our list is 5. So 5 is a rational number. We knew that from up here, but now I want to see, is it any other type? Well, 5 is a rational number. It's also an integer. It's also a whole number, and it is also a natural number. So I'm actually going to list 5 inside the natural numbers box because that is included inside the whole numbers, which is included inside of the integers, which is included inside of the rational numbers. So if I have a number that I can list all the way down into the natural numbers, it means that it's really all of the prior ones as well. All right, let's look at 2.3. So 2.3 is a rational number, but is it an integer? So is 2.3 an integer? What do you guys think? So 2.3 is not going to be an integer, so I'm going to list 2.3 out here with my rational numbers only. Okay, the next one we have is this 1.333 repeating. 1.333 repeating is a rational number. It is not an integer, so I have to just list it way out here. The next one we have is negative 1/4. So negative 1/4 is a rational number, but it is not an integer as well, so that's stuck out here. So we can kind of see there's only special cases really where I get to be an integer or a whole number or a natural number. Let's look at some more examples. This negative 1,000. So negative 1,000 is a rational number. Is it an integer? So negative 1,000 is also an integer because remember the integers get to include all the positive and negative counting numbers. So I would list negative 1,000 under the integer box. The reason it's not going under the whole number box or the natural number box is because it's negative. So whole numbers take only from 0 all the positives, and then natural numbers start with 1 and take all the positives. Our last number to figure out where it goes is 0. So 0 is a rational number. It is also an integer, and it's also a whole number, so I could list 0 inside the whole number box, but I can't put it inside natural numbers because natural numbers only start with the number 1 and move up from there. So big takeaway from the real number system is the first thing is I'm either a rational number or I'm an irrational number. I cannot be both of those types. I'm one or the other. But within the rational numbers, I have a couple. I could be an integer, so I could be an integer as well as a rational number. I could also be a whole number, which would mean whole numbers are also integers, which are also rational numbers. And then the kind of best case, or has the most cases, would be a natural number, which is also a whole number, an integer, and a rational number. So we can see that there are some examples like 2/3, this 2.3, and these other two that are just rational numbers that don't get to go inside of the integers box. Then there's some examples like negative 1,000 that's both a rational number and an integer. And then we also have a special case where 0 is both a rational number, an integer, and a whole number. And then our most special case would be natural numbers. So 5, for example, which is both a rational number, an integer, a whole number, and a natural number. Okay, let's go through some examples of how we would list these out. So I'm going to leave that box up there so we can kind of see how they're all self-contained inside each other. Let's look at our first example. It says, for each number below, name all the subsets of real numbers that number belongs to. So we're starting with 100. So the first thing you want to think about is that a rational number or an irrational number? So pause the video and you guys decide, is 100 rational or irrational? So since I could write 100 as 100 over 1, this is written as a fraction, so 100 is a rational number. Now that I know it's a rational number, I want to look inside of the rational number box. The next thing it could be is it an integer? 100 is an integer because I'm writing it as 100 over 1, so it's one of our counting numbers. So it is also an integer. The next thing it could be is a whole number. So 100 is a whole number since it's positive. And whole numbers, remember, start with 0 and do all the positives. And then the next thing would be, is it a natural number? Yes, it is also a natural number since it is bigger than 0 and is a counting number. So 100 is all 4 of these. It's a rational number, an integer, a whole number, and a natural number. So when they say name all the subsets of the real numbers that it belongs to, I might have up to 4 that something could belong to. And in this case, here's an example where 100 is all 4 of those. You'll notice the only thing it is not irrational. Because remember, we cannot be rational and irrational at the same time. Okay, part B, negative 16. Well, first thing I need to decide is it rational or is it irrational? Negative 16 is a rational number. The next thing I want to think about is, well, since it's a rational number, could it be an integer? That would be the next step. Negative 16 is an integer because integers get to include the negative numbers. So if I scroll back up to that definition, remember integers get to include all of these negative numbers over here. And if we kept going to the left, negative 16 would be on there. The next thing it could be is a whole number. Well, whole numbers start with 0 and just go positive. So if I look at that definition of whole numbers, remember they start with 0 and just go in the positive direction. So negative 16 cannot be a whole number. And because it's not a whole number, there's no way it can be a natural number. So negative 16 is just a rational number and an integer. Okay, let's look at example C. So example C says negative 2.111 repeating. First thing I have to decide, is it rational or is it irrational? Why don't you guys pause the video and make a decision on if it's rational or irrational. Okay, part C. This is a rational number because although it's not written as a fraction, it is a terminating decimal, or in this case, it's a repeating decimal. So negative 2.111 repeating is a rational number. The next step it could be would be an integer. Well, to be an integer, I have to either be a positive or a negative counting number, and this is not a negative counting number, so I'm not sure why I put the comma then. I only have one answer to this. So negative 2.111 repeating is just a rational number, and that's okay. We saw cases up here where I could just be irrational and I would not be any of the other 3 subcases of that. Okay, 5 halves. So 5 halves is a rational number as well, since I can write it as a fraction. And I cannot reduce this down any further to just a single numerical number, so it's not an integer, so 5 halves is just a rational number. Okay, example E, square root of 5. Why don't you guys decide, pause the video, is it rational or is it irrational? Because we have to start there. Okay, square root of 5. Now, if you weren't sure, you could have plugged it into your calculator to see. 5 is not a perfect square, so the square root of 5 is going to give me an irrational number, since that 5 is not a perfect square. Now, within the irrational numbers, there's no other subtype, so I don't have to worry about all these other special cases, because once I'm an irrational number, that's the only thing I could be. Okay, let's look at F. Why don't you guys pause the video and decide what F is? Is it rational or is it irrational? And then come up with all the subsets that it might be. Okay, let's check F. So F is written as a fraction, so it is a rational number then. And it's really tempting to want to say, well, that's all it is. If I go back to D, I had a fraction which was 5 halves, and we said it was a rational number, and we didn't list anything else. The difference here is that negative 10 over 2 can be simplified. So negative 10 over 2 is the same thing as negative 5. So I want to make sure I'm looking at the most simplified form here, because that's really going to tell me about this number as much as possible. So negative 5 is a rational number, and it's actually also an integer because it can be simplified down. So unlike the 5 halves, which I couldn't simplify down, because I could simplify negative 10 over 2 to be a single negative counting number, then I also get an integer. Now if I'm here, the next step that it could be inside of an integer would be a whole number, but whole numbers, remember, are 0 and all the positives, and because I have a negative, it is just going to be an integer. Okay, last example. Why don't you guys pause the video and list all the subsets that you can think of that the square root of 4 belongs to. Okay, let's check it. So I have a square root here, so it's really tempting to want to say, oh, it automatically has to be an irrational number. But that's not the case if it's a perfect square. And the square root of 4 is equal to positive 2, which means that I actually have a rational number in disguise. So I don't want you guys to think that just because we see a square root, it's automatically irrational. It really depends on, can I simplify that further? And in this case, we can, so it is a rational number. The next thing I could have would be an integer, and 2 is an integer. It is a positive counting number, which means it's also a whole number, because remember, our whole numbers start with 0 and go all the positive counting numbers. And it's also a natural number, because natural numbers are all of our positive counting numbers. So 2 is going to be all 4 of these things, just like 100 was as well. So there's some examples listing all the subsets of real numbers. Remember, when you're going through these, the first thing you want to think about is it rational or is it an irrational? And if it's an irrational number, then you're done. That's the only thing it could be, like we had on example E. If it's a rational number, I really have to think about all the other subsets within there. Is it an integer? Is it a whole number? Is it a natural number? So I think this diagram is helpful so that we can really see how they're kind of contained inside of each other. And then don't forget about the definitions of natural numbers, whole numbers, and integers. And that will be the end of this learning.